In the following video, we're going to combine all the concepts together of transformations. We'll be doing with translations, reflections, and dilations all at one time. So this one involves a little bit more thinking on how do we graph it, because we'll be doing left-right movements, up-down movements, and compressing, reflecting. So let's first look at this example. The function y equals -1/2 times x minus 5 squared plus 2.5 can be used to represent a parabolic archway. Describe the transformations in the function and then graph. So to describe the transformations, we need to look at the idea of a times x minus h squared plus k. So if I look at that, I see my a value is -1/2, my h value is 5, and my k value is 12.5. Remember, your h value is 5 because you are subtracting 5. So h value is positive. And now what we do is we take these values and we're going to determine what our transformations are. So let's first start with a. It says a is -1/2. And so first, since a is negative, we say it reflects over the x-axis. And that's because our a value is negative. Now the size of a tells you what type of dilation occurs. So since a is 1/2, that is between 0 and 1. So a is between 0 and 1, which means that we are going to have it compress vertically. Then we go to h of 5. Remember, h is your horizontal, your left movement, your right movement. And since h is positive, we go to the right 5 units. K is your vertical movement, your up, your down movement. And since K is positive, we go up 12.5 units. And so graphing this is going to be a little bit more difficult because of the shape along those lines. We're just going to kind of sketch one because of our graph. We're going to imagine we go by 4s on our x-axis. And so that means, this would be 4, this would be 8, this would be 12, this would be 16, and this would be 20. We can go by 4s on our y-axis too, so then this is 8. We have 16. Actually, this would be 24 on both of these. And so what we do is we take our vertex, it goes to the right 5. So here's 4, 5. It goes up 12.5. So there's our vertex. We go from 0, 0, right 5 units, up 12.5 units. It reflects over the x-axis, which reflects over the x-axis means that it opens down. And so my parabola is going to be going downwards, and it compresses vertically, which means it stretches out. It slowly decreases. So this is just a sketch of the parabola. We'll do another example that's a little bit more effective with dealing with the transformation. So let's go down to example 2. Describe the transformation. We have another absolute value. So again, we're going to identify a, absolute value of x minus h plus k. So if we look at this, a is -1/4. H, you are subtracting. In order to make that subtraction sign become a plus sign, you subtract a negative. So h is -4, and k is -2. So again, we deal with our describing transformation. Since a is negative, we say it reflects over the x-axis. The size of a is between 0 and 1, so that means it's going to compress vertically. H is negative, so your negative numbers are towards the left on the x-axis, so go left 4 units. And your K is negative, so you're going down 2 units. So let's graph the original function. It's an absolute value, so the original absolute value of 0 is 0, of 1 is 1, of 2 is 2, of 3 is 3. Absolute value of negative 1 is 1, of negative 2 is 2, of negative 3 is 3. So again, I'm going to use a dashed line. So this is my parent function, the parent absolute value function. I'm going to take this graph, I'm going to reflect it over the x-axis, I'm going to compress it vertically, I'm going to move it left 4 units, I'm going to move it down 2 units. I like to do the left and right movement first, and the reason why is it provides me with the location of your vertex. Your vertex is actually your h value and your k value. Because if you think about it, from 0, 0, I go left 1, 2, 3, 4 units, go down 1, 2 units. That's the coordinate, negative 4, negative 2. So that's why your HK values are nice. And then it reflects over the x-axis, which remember that just means it's opening downwards. And now we need to compress vertically. So let's use that shortcut. We have a negative 1/4 for our A. And the shortcut we learned for absolute value graphs was we can go down 1 to the right, 1, 2, 3, 4. Down 1, 1, 2, 3, 4 to the right. That's going to give you one side of the V. And then just reflect it. Go down 1, left 1, 2. And we're going to go to the left 4 units. So let me just take this information that we have. And I'm going to shrink it down so, to give myself some room. Because I'm going to go to the left 4 units that's off the graph. So go down 1, 1, 2, 3, approximate at 4. And then we're going to use our solid line. You see my graph is compressed vertically. It looks like it was smashed down for my V shape for it. And I could change the color as I've been doing so we can see our transformation graph as a different color. It went to the left 4 units down, it reflected open downwards, and then it compressed vertically, and we used our slope of negative 1/4 to find the other points. And so that is how we deal with transformations. I would identify your A, your H, your K, and then work through each one separately on what the values do and go from there. The nice thing about finding your H and K is it gives you the coordinate of your vertex. That's also true for quadratics. I mean, if I look at this, my H and my K value were 5 and 12.5. So if I were to think about this, my vertex is my H and my K. So I get 5, 12.5. If I already look, 5, 12.5. That is my vertex. So that's what's nice about your H and K value. They give you the coordinate of your vertex. It allows you to know where to start your graph. Identify your A, your H, your K, and then put to memory application the idea of translations, reflections, and dilations.